Right now we have a small session just to give the opportunity to some open science initiative to be advertised. So we decided to do this kind of short talk. It's only 3 minutes, and you will have like finally 4 of them. And I will ask again the speakers to stick to the time that is a format of 3 minutes basically, and then I will have some panel to remind you when you have to stop talking and we have to go to the next slide. So it will be short, and we selected some very interesting initiative that we thought would be worth showing. So I will ask the first speaker, Jean, to come here, and and perhaps for the next one, I mean, please, I don't know where you are. You are 4 of you. There are 4 of you, and then please come on the stage when you see your presentation on the screen.
Okay. So hello everyone. So I'm a neuroscientist, right? I'm heading a group together with 2 neuroscientists here at the ICM. And as an academic, I probably, as most of you, or many of you in the future, I'm a member of some editorial boards in some journals. So, for example, I'm part of the editorial board of PLOS Computational Biology. So PLOS is already open science, right? So you pay when you write, you don't pay when you read, effectively. But, I mean, where does the publication fees come from? I asked a question to the staff 2 years ago and never got an answer. I mean, who does the work? The authors, the reviewers, the editors. And then this thing happened about 6 months ago. So it's an initiative from 3 researchers in neuroscience. That's a journal, Neurons, Behavior, Data Analysis and Theory. So it's a true community journal. So effectively, it is handled only by academics. So there's no professional publisher involved at all. And the thing that seduced me, and I'm now part of the editorial board of that journal as well, is that it's free to write. In fact, it costs $10 to submit here. So there's no, so the archiving system is, there was a negotiation with the archive system from Cornell. And then so that stuff is effectively free to write, free to read. So what is the scope of the journal? That's my bit of advertising now. Data theory and analysis explicitly. So of course that includes behavior-only studies, software development, system neuroscience, theory-only studies, data analysis methods, etc. So what do you do for manuscript submission? Well, effectively the way it works is as follows. So you name 3 editorial board members. I'm going to show you names later on, you'll see. The editorial line is as follows. Editors are instructed to handle papers that they consider running as a journal club paper for their own lab. I'm doing the editorial sort of like on the side business for quite some years now. It's the clearest editorial line I've ever received. And then the rule is as follows. If the 3 editorial board members you name all decline to handle the paper, it is automatically rejected, so you can go very quickly onto another journal. So who is on the board? In neuroscience, it's a bit of an all-star editorial board. Apo Ivarinen, Adam Kepex, and John Liu, Bruno Everberg, Daniel Bassett, Daphne Shuami, Jack Allen, Jeff Beck, John Dutwichen, Kathleen Cullen, Larry Maloney, Michael Platt, Nathaniel Doe, Peter Dayan, Quentin Huss, Rose-Paul Raquel, Niv, and others. Okay, so these are the big names. So this is not something like, that is like on the side of the community. These are the main key players here. So please submit. It's now open. That's it. I'm done.
All right, so the next, oops.
Next one is
all right, I thought you put them.
Next one is Filipe.
Okay. Filipe, Carvalho. Well, I let you guys introduce yourself. Unfortunately, we don't have too much time. I just have one more thing to say before the next speaker, is that it could be frustrating because there are a lot of information that is on the presentation you may not have time to note down or things like that. All the speakers, almost all, we have to ask a few of them, agreed to share the presentation, and it's video recorded. So please don't hesitate to go back to this online after the meeting. Yeah, it's the only thing I wanted to say. And one thing is, from Marie Garambois, she was talking about this training for students. I don't know where this information could be displayed, but I think we'd be interested to have also.
Thank you for this opportunity to show hardware. Let's talk a little bit about hardware. You need hardware to make your science. Thanks for this opportunity. It's the first time that I'm showing this outside the Champolimaud Foundation Institute boundaries. And even without any advertising, we already have 10 institutes that ask for this hardware that we ship already assembled, ready to use. And we also will be part of the International Brain Laboratory Initiative, where they will use our technology during their behavior experiments. This is hardware for behavior, typical rodents and flies. This technology raised from dozens of meetings with PIs, students and postdocs, where we listen to their problems and we try to solve them. The most named problems was uniformization. So they want to learn one device, and once they learn one, they can then use all the others. Synchronization. Low size files, so they don't want huge file size, they want small file size but with the data that they need, and configurable hardware. So what we have, this is open source and is a growing family of devices. I'm highlighting three features that we like the most. First is synchronization. All the devices that we have, all the boards, are synchronized through hardware. So you don't have any latency with the software, because all comes from hardware, the synchronization. So you have one device that will send clock and information of the time to all the others. So once you have this, and one of these, or two or three or four or whatever, they are already synchronized. You don't need TTL signals from one side to the other. Then is configurability. You configure each device to your task only, and you save all the configuration into the device. So if you turn off the device, you start your behavior tomorrow, they will have all the initialization. You don't need to do it. And it's also based on events. So all the devices are always sleeping unless something occurs, and that's what is saved and notified. We use Bonsai to program our state machine. Bonsai is free to save the binary files. And then we have lots of tools to extract the necessary and the data that you really want into the typical code and language that you use. And you have also synchronization with the video. How do they look like? They look like this, bare, or they all have an acrylic case to protect under those complex environments, and they also can be stacked because they all share the same size. This is the list of the devices that we have right now. These are really cool devices, and they really do what they were supposed to do. What is also important sometimes. I'm highlighting only one of the devices, so it's the behavior that we use for behavior. You can do many complex tasks with this guy with 89 bucks, or you can, with 100 you can buy several of these, and with 200 you can do really awesome tasks. Complex tasks. And we have some videos that this is Archimedes, a lever that you track the lever all times, and you have some thresholds that are configurable. This is the wireless accelerometer. It has 9 axes. We are playing it, so You can do optogenetics wirelessly also with it. This is an array of LEDs that are used for optogenetics on flies, and this is the load cells reader, and we are tracking a mouse going through a corridor with lots of load cells, and you can track the force that is applying to each of the cells. If you want to know more, we can share designs, we can share devices already assembled, and for collaborations, please visit this website. We are doing it as I'm speaking, so probably later this week we'll have really cool videos, this kind of videos, and all the manuals to start with the material. So we are an open source team, and we consider ourselves a mean to an end. So we try to stay humble and do this for the right reasons, because we are just a mean. Thank you.
Thank you. The next one is Pierre. There he is.
Hello everyone. Timeflux is a free and open source solution for the acquisition and real-time processing of biosignals. You can use it to build brain-computer interfaces, neurofeedback applications, or to quickly test a new protocol. It runs on Windows, Linux, and macOS. It is meant to be easy to use. You describe your processing pipelines using a simple YAML syntax. Every step in your analysis is a node. You can link these nodes together in graphs, and you can combine these graphs into applications. It comes with everything you need to get started, including lab streaming layer, so you can connect with a large range of EEG devices, stimuli presentation software, etc. There are all the classical digital signal processing tools you may expect, an implementation of the publish-subscribe pattern, which allows you to aggregate data from multiple sources and also to listen to only what you really need. We can record all your data and events into the HDF5 file format, and we can also play back this data in real time. There are machine learning tools, so you can classify your ERPs or brain states, and you can visualize your signals in real time in a web browser. If that's not enough, you can write your own plugins in Python using the tools you already know. There is SciPy for scientific computing, Pandas for tabular data, Xarray for multidimensional data, and obviously scikit-learn for machine learning. Timeflux is still an early stage project. It's not feature complete yet, but it's stable enough to be used in production. Meanwhile, we invite you to connect and to get in touch at timeflux.io and to let us know how we can help you. Thank you.
All right, thank you. And the next and last one, I think it's Marion, yes. Pointeur.
Yep.
Et prochaine diapo.
Okay. Merci. Okay, so hi, and thanks for the opportunity, and thanks for all the great talks this morning, which have made it actually really easy to introduce our idea or our project. So I'd like you to imagine a world where preprints are peer-reviewed for free, where we no longer rely on expensive journals for validation and feedback. So I'd like to introduce our project, Peer Community in Circuit Neuroscience. So it sits within the broader community of Peer Community In, or PCI, which is a non-profit that brings together communities of researchers to peer review preprints in their field for free. So, there are already 3 growing PCI communities in evolutionary biology, in ecology, and in paleontology. And we think that there's a real need to set up something similar in neuroscience because preprints are rapidly growing in popularity. So if we look at the figures on bioRxiv, we can see that neuroscience currently makes up the largest subcategory on bioRxiv, which is great. I was going to talk a little bit about why preprints are great, but I feel like I'm preaching to the choir here. We're all already convinced in terms of increasing visibility, not being hidden behind a paywall, and kind of encouraging instant dissemination of scientific findings. So another thing that's a potential benefit of preprints is to enable direct feedback to authors. However, unfortunately, this really isn't happening as much as we'd like. So if you look at the graph on the right, you can see that whilst the number of preprints are rapidly increasing, the percentage of those that are receiving comments is kind of dwindling to below 5%. So we're really not getting the feedback that we want. Another problem with preprints is that there's no quality control. So everything and anything can be uploaded, and it means that readers have absolutely no way to distinguish between a preprint that's scientifically sound and one that isn't. It also means that authors who make a really great paper have no way of validating that. So this is where a system like PCI, which aims to peer review preprints, comes in. It works very much like a journal. So you have your preprint, you submit it to PCI. If one of PCI's recommenders, who act very much like editors, decides to take it on, it gets sent out for peer review. And if it meets the required standards, it then gets a stamp of approval, which is essentially a PCI recommendation, which is a citable short text written by the recommender, which is then attached to the preprint, and it's on bioRxiv. This means that the preprint is validated, the authors get feedback, and importantly, all of the reviews are made publicly available, so the entire process is transparent. So how is this service free? Well, it's in the name. So this is very much a community project. It depends on authors choosing to upload their work as preprints and choosing to submit it to PCI. It relies on a large group of recommenders who act very much like editors, but because of their numbers means much less work than being a journal editor. So we expect any one recommender to only have to take on 1 or 2 recommendations per year. But this relies on building a big pool. And obviously it relies on reviewers to peer review for free, but this is no different to what we already do. We peer review for free for journals, and we peer review in our journal clubs, as has already been mentioned. So this is very much early days. We're only just getting started, so we're looking to recruit everyone. We need recommenders, we need authors to upload all their work as preprints and to submit it to PCI. And yeah, so we're really interested to hear your thoughts with Vincent and Mahesh, who are kind of co-founders, and please join the community.